Okay, and welcome to video 5, the last video. This one is quite popular, requested by 2 people. 11.3, question 2. Barry throws a stone from the beach up towards the top of a cliff. So let's draw a cliff. Beautiful drawing here. Here's the ocean. And Barry's standing down the bottom here. There's an assumption already. The cliff is 8 meters tall. So we know it's 8 meters. He's thrown the stone, it's just reached its pinnacle after 8 meters. It accelerates downwards at about 10 meters per second. So the acceleration equals negative 10 meters per second squared. How fast does he throw his last stone? So we want to know the initial velocity. So we start with the acceleration, and you need to use the knowledge that you should be aware of, that the integral of acceleration with respect to time is equal to the velocity. So therefore velocity equals the integral of negative 10 dt, which in this case will equal negative 10 t plus c. Now we'd like to be able to substitute in some sort of known value for velocity here to calculate the constant, but we don't know any value for velocity, least of all the initial value, because that is what we're actually trying to find in the question. So then we need to go a step further, and I'm going to call this C1 now, the constant, the first constant. And the integration of velocity dt is equal to displacement, which I'll call s. So s is equal to the integral of velocity dt, which equals the integral of negative 10t plus c1 dt, and this is equal to negative 5t squared plus c1t plus c2. But what we do know is that at time t equals 0, d, I'm not using d, s equals 0, the displacement. So now we have this new situation. 0 equals negative 5, 0 squared, plus c1, 0, plus c2, which leads to c2 equaling 0 itself. So now we have our displacement s is equal to negative 5t squared plus c1t. What we know is that at the maximum displacement, max s, we know that the velocity equals 0. And we can use this fact to help us. So let's first of all calculate the maximum displacement. First of all, we know that the maximum displacement happens when s equals 8. That's what we're working with. So we let s equal 8 in this equation, and we come out with 8 equals negative 5t squared plus c1t. Now we don't know t and we don't know c1, but we can do a little bit of manipulating with this equation and come out with 5t squared plus c1t minus 8 equals 0. Now we'll call this equation 1. We also know that velocity equals negative 10t plus c1. But we're working in a situation at the moment where velocity equals 0 because s equals 8, so it's at the maximum. So therefore, negative 10t plus c1 is equal to 0, and c1 is equal to 10t. Now working at this very specific moment, we can then substitute in c1 equals 10t to get 5t squared plus 10, that should be a minus up there, so I hope somebody spotted that while you're watching the video. This should be a subtraction, so this is a subtraction. Minus 10t squared minus 8 equals 0, leaving us with negative 5t squared minus 8 equals 0. And this, of course, is plus 8, so that was wrong as well. And that gives us t squared equals 8 divided by 5, and t equals the square root of 8 divided by 5. 8 divided by 5 is 1.6. The square root of 1.6 is probably about 1.3. We don't need to know exactly what it is now. We just need to know that is the time when the maximum occurs. So if we know the time when the maximum occurs, then we know the time when the velocity is 0. So we can go back to our original equation for velocity. V equals negative 10t plus c1, and we can substitute in 0 equals negative 10 times the square root of 8 over 5 plus c1, and we come out with c1 is equal to, and I'm just going to calculate this on my calculator. So I am doing the square root of 8 divided by 5, and I'm getting that times 10, and I get 12.65. So this is equal to 12.65. So I've got velocity equals negative 10t plus 12.65, which implies, of course, that if at t equals 0, initially the velocity equals 0 plus 12.65, which means the velocity is equal to 12.65 meters per second. And the question asked for, go back up the start, how fast does he throw the last stone, and what is it in kilometers per hour? We're not even going to ask you this in the exam because it's not important to you, but you would divide by 1000 to turn the meters into kilometers, multiply by 60 to turn seconds into minutes, multiply by 60 to turn minutes into hours, and you would have your kilometers per hour. Should be approximately 40 to 45. Okay, and that's the end of that question.